Hello, this is Mr. Green and welcome to Lesson 8.2, Acceleration. This lesson will learn to identify average and instantaneous acceleration, calculate average acceleration, and learn to interpret acceleration graphs. Before proceeding, please take out something to write with and something to write on. You will find the notes helpful on assignments, activities, and assessments. The approximate duration of this lecture is 10 minutes. By the end of this lesson, you should be able to identify changes in motion that produce acceleration, describe examples of constant acceleration, calculate the acceleration of an object, interpret speed time and distance time graphs, classify acceleration as positive or negative, describe instantaneous acceleration. The Ferris wheel constantly changes velocity as it rises and falls. Describing changes in velocity and how fast they occur is a part of describing motion. How are changes in velocity described? The rate at which velocity changes is called acceleration. In other words, acceleration is how fast is something going faster. In science, acceleration applies to any change in an object's velocity. Acceleration can be caused by a positive or increasing change in speed or a negative or decreasing change in speed. Deceleration is an acceleration that slows an object's speed. Freefall is the movement of an object toward Earth solely because of gravity. The unit for velocity is meters per second. The unit for acceleration, then, is meters per second squared. This unit is typically written as meters per second squared. Objects falling near Earth's surface accelerate downward at a rate of 9.8 meters per second squared. Each second an object is in free fall, its velocity increases downward by 9.8 meters per second every second. The stone initially has a velocity of 0 meters per second. After 1 second, the velocity of the stone is 9.8 meters per second. 1 second after release, the stone travels at a velocity of 9.8 meters per second. After another second, the speed of the stone is 19.6 meters per second. By the time the stone hits the ground 3 seconds later, it is moving at a blistering 29.4 meters per second. That's almost 66 miles per hour. The change in the stone's speed is 9.8 meters per second squared, the acceleration due to gravity. While these cyclists are traveling at a constant speed during a turn, they are also accelerating. Being that acceleration is a vector, a change in direction is an acceleration. Another example of this is carousel horses. They undergo constant acceleration because they never move in a straight line. Sometimes motion is characterized by changes in both speed and direction at the same time. Passengers in a car moving along a winding road experience rapidly changing acceleration. The car may enter a long curve at the same time that it slows. The car is accelerating both because it is changing direction and because its speed is decreasing. Sometimes motion is characterized by changes in both speed and direction at the same time. Passengers in a car moving along a winding road experience rapidly changing acceleration. The car may enter a long curve at the same time that it slows or speeds up as it travels down a hill. The car is accelerating both because it is changing direction and because its speed is decreasing. How can you calculate acceleration? You calculate acceleration for straight-line motion by dividing the change in velocity by the total time. Acceleration is the rate at which velocity changes. V sub I is the initial velocity, V sub f is the final velocity, and t is total time. If the velocity increases, the acceleration is positive. If the velocity decreases, the acceleration is negative. If you are coasting downhill on a bicycle, your velocity increases and your acceleration is positive. If you continue coasting on level ground, your velocity decreases and your acceleration is negative. Acceleration and velocity are both vector quantities. To determine a change in velocity, subtract one velocity vector from another. If the motion is in a straight line, velocity can be treated as speed, and acceleration is the change in speed divided by the time. Let's work on an example problem together. A ball rolls down a ramp, starting from rest. When you see the word rest, the velocity is 0 meters per second and is the v sub I, the initial velocity for this equation. After 2 seconds, this is your delta t or change in time, the ball's velocity is 6 meters per second, our v sub f, the final velocity. What is the acceleration of the ball? Having read the problem, we know our knowns and unknowns, shown to the bottom left, and the equation we need, equation 1. Substituting in our known values gives us equation 2. From there, we simplify. 6 meters per second minus 0 meters per second is 6 meters per second. Divided by 2 seconds is 3 meters per second squared. The average acceleration for the ball is 3 meters per second squared. A car traveling at 10 meters per second is the v sub I. The car begins to decelerate steadily. It comes to a complete stop in 20 seconds. A complete stop means that the car has a v sub f of 0 meters per second. What is its acceleration? Having read the problem, we know our knowns and unknowns, shown to the bottom left, and the equation we need, equation 1. Substituting in our known values gives us equation 2. From there, we simplify. 0 meters per second minus 10 meters per second is negative 10 meters per second. Divided by 20 seconds is negative 1/2 a meter second per second. The average acceleration for the ball is negative 1/2 a meter per second squared. An airplane travels down a runway for 4.0 seconds. This is the delta t, with an acceleration of 9.0 meters per second. What is its change in velocity during this time? We will assume that the plane started from rest since we were giving no other information. Having read the problem, we know our knowns and unknowns, shown to the bottom left, and the equation we need, equation 1. Rearranging equation 1 to solve for velocity gives us equation 2. Substitute our no values to give us equation 3. The final velocity of the plan is 36 m/s, about 80 miles per hour. You can use a graph to calculate acceleration. Graph speed on the vertical axis and time on the horizontal axis. The slope is a change in speed divided by a change in time, which is equal to the acceleration. The snowboarder's acceleration is positive. The acceleration is 4 meters per square second. Constant acceleration is represented on a speed-time graph by a straight line. The slope of the line is the acceleration. The graph is an example of a linear graph, in which the displayed data form straight-line parts. Constant negative acceleration decreases speed. A line sloping downward represents the bicycle decelerating on a speed-time graph of a bicycle slowing to a stop. The change in speed is negative, so the slope of the line is negative. Accelerated motion is represented by a curved line on a distance-time graph. In a nonlinear graph, a curve connects the data points that are plotted. Compare the slope of the curve during the first second to the slope during the fourth second. An increasing slope means that the speed is increasing. Instantaneous acceleration is how fast a velocity is changing at a specific instant. Acceleration is rarely constant, and motion is rarely in a straight line. Acceleration involves a change in velocity or direction, or both, so that the acceleration vector can point in any direction. The vector's length depends on how fast velocity is changing. For an object that is standing still, the acceleration vector is 0. The rate at which velocity changes is called acceleration. Freefall is the movement of an object toward Earth solely because of gravity. Acceleration due to gravity is 9.8 meters per second squared. Acceleration can be the result of a change in direction. Constant acceleration is a steady change in velocity. Acceleration is the ratio of a change in velocity over a change in time. You can use a graph to calculate acceleration. The slope is equal to the acceleration. A distance-time graph of accelerated motion is a curve. Instantaneous acceleration is how fast a velocity is changing at a specific instant. By now, you should be able to identify changes in motion that produce acceleration. Describe examples of constant acceleration. Calculate the acceleration of an object. Interpret speed time and distance time graphs. Classify acceleration as positive or negative. Describe instantaneous acceleration.
If I have seen Father, it is by standing upon the shoulders of giants. We hope you enjoyed this lesson.